Welcome back, folks, to Scripting for Linguists. In this episode, I have this question for us. When performing Keyness Analysis, which is faster, Python 3.13 or Julia 1.11? The reason I asked this question is because in a previous video, linked in the description of this video, I found that both Python 3.13 and Julia 1.11 are faster than their previous versions of themselves. But importantly, Julia 1.11 was twice as fast as Python 3.13 when inserting 230 million words into a dictionary to get their frequencies. And that surprised me. Julia has made great leaps and bounds of progress on speed with its dictionary. Good job, Jules and the Julia creators. Python also increased in speed, but not as much as Julia. So I'm curious to know if that speed up in inserting items into a dictionary helps Julia be quicker with Keyness Analysis, which is a corpus linguistic technique. Just to give a quick little description of it, what it is you have a target corpus or a target collection of text, and you have a reference corpus or a reference collection of text, and you want to know what are the keywords that seem to typify the target corpus in comparison to the reference corpus. That is, what is this target corpus about in reference to the reference corpus? And so I'm assuming that Julia is going to be quicker than Python because of the fact that Julia's dictionary is now quicker than Python's dictionary. And so because you have to get the frequencies of the words in the two corpora being the plural of corpus, right? Where you get all the frequencies of all the words and all the files in the target corpus, and then you get another dictionary with all the frequencies of all the words and all the files in the reference corpus. And there's a little bit of math involved. It's not crazy to do that. Let's just take a look here. So here is a book written by the corpus linguist Václav Březina, who is a corpus linguist who works at Lancaster University in the UK. Shout out to Václav if he's watching. If you're watching, you know him, send it to him. Anyway, in his book, Statistics in Corpus Linguistics, a Practical Guide, he describes the log likelihood metric. And on the left-hand side, I have the formula. And here's the textbook in a Kindle edition, right? It's not too crazy. It's just some multiplication and addition and division there. And there's a log, natural log there. It's not too crazy. The math is you simply take the observed value of the word in the target corpus, divide by the expected value of that word in the target corpus, take the natural log, times it by the observed value of that word there. You do the same thing in the reference corpus. You sum those up, you times it by 2. So you end up with a log likelihood score for each word in the target corpus. So the math's not too crazy, just some multiplication and addition, and there's a natural log there, which, not too bad. So let's take a look at my code in which I do that. So here's my Python. Let's just go down to the little math part right away. The math part happens right in here. Well, I guess we should talk about the fact that we first get all the frequencies in the target corpus. In this case, my target corpus is 230 million words across almost 40,000 files in the Spotify podcast data set. That'll be my target corpus. So it first has to go through and get all those frequencies and all those files in that target corpus. My reference corpus is the Brown corpus, which is one of the OGs, probably the OG corpus of the modern corpus linguistic world, published in 1961 at Brown University. And it was, a slick corpus back in the day because it had 1 million words. These days, 1 million words is pretty small. But it's a well-balanced general purpose corpus of 500 files and 1 million words. It was really cool. So that'll be my reference corpus. So what are the words that seem to typify, or what is the aboutness of a podcast data set corpus versus a general English corpus? And so I get the frequencies of all the words in the podcast data set, the frequency of all the words in the Brown general purpose corpus, and then the math happens down in here. And we don't need to really look at it too closely. It's simply implementing in Python what we just saw a second ago on that little formula in the the book. There it is. And so there's my Python. And I just did a direct translation to Julia. Very direct translation into Julia, that same idea. There's the actual mathematical part of it right there. So that is what we're looking at here. Good. So what I've done is I have run it 10 times in Python and Julia, did 10 trials. And I'm going to look at the top 25 words, keywords. They have to have a minimum frequency of 3 in each corpus to be considered. Great, so here it is. I do 10 trials and just time that that Keyness Analysis calculation there. Good, and I save it out to a CSV file so we can look at it side by side. Okay, so I do that for both Python and Julia there. Great. So now we're ready to jump over to our old friend, at least an old friend for me, R. Here it is. I have them already plotted up. And I just simply give the dots themselves because they're so close together that a box plot wouldn't be super helpful here. So on the left-hand side, we have Julia version 1.11.1, the current release at the time of recording this video. You can see that we're getting a median or a mean right around 65, between 65 and 70 seconds to do Keyness Analysis. Again, the target corpus has 230 million words across 40,000 files. The reference corpus has 1 million words across 500 files. And to do that Keyness Analysis, it's taking about 65 to 70 seconds in there in Julia 1.11.1. On the right-hand side in blue, we have the 10 trials for Python 3.13.0, which is the current release at the time of recording this video. And it's right around 80 to 83 seconds, between 80 and 83 seconds up there. So, yeah, what do we see here? We see that Julia is a little bit quicker, not twice as quick like we saw in the previous video when just simply inserting words into a dictionary. But yeah, we see that Julia is quicker than Python with this Keyness Analysis. So let's jump back to our research question. Our research question is right here. When performing Keyness Analysis, which is faster, Python 3.13 or Julia 1.11? Julia 1.11 is quicker, but not twice as quick as we saw in a previous video about just simply inserting into a dictionary. So I would say this is probably about a fifth quicker. So on the bottom left of this plot, we have 0 seconds, right? And it took Julia about 65 to 70 seconds, and Python 80 plus seconds. So maybe it's maybe a fifth quicker in Julia than in Python. But yeah, so my next follow-up question I'll have to look at in a future video is, where is Python making up speed on Julia? If Julia's dictionary is about twice as fast as Python's dictionary right now, then somewhere Julia is slower than Python in the overall workflow, the algorithm of doing Keyness Analysis. But anyway, there we have it. We have another result. And Julia, I am more and more impressed with Julia. I salute the creators who are making it quicker and quicker and made the dictionary much quicker with this current release of 1.11. And it's super easy to use, but it's quick. Another follow-up question I have is, what about the big bad boy Rust? The Rust language, right? It's a compiled language, super quick. That's another topic for another video. But thank you for watching. Hope you enjoyed this. Give me a like if you liked it. Comment if you'd like to. Subscribe. And join me next time. Thanks. See ya.